Okay, so we're going to learn about product and quotient rule. Okay, before we get into the product rule, I did want to look and say, why do we even need a product rule? Okay, look at this problem number 1. If I asked you to find that derivative, okay, what do you think algebraically you would need to do to that in order to even use the power rule? Distribute and multiply and all that. And that's really not that hard, but it's something that we don't necessarily want to have to do. And then if we skip over to 2, ooh, I can't distribute into sign. So I need a new rule in order to do more derivatives. And there are more rules to come after this, but today we're just going to focus on these 2. All right, so we have this f of x, and then product we know means times, so it's f of x times g of x, if I want to take that derivative. All right, I'm going to give you the rule, like as a formula, and then I'm going to kind of talk through it a few times and do some examples so that you can know it better, okay? If you're not good at memorizing formulas, that's okay, you can still do this. But I will not give you the formula on a test or a quiz. So this is how you do this. You take derivative of the first function, which would be in the formula f prime of x. Then you multiply by just plain g of x. Okay, and that's the first half. Then we have a plus. Then you just write regular f of x times the derivative of g of x. Okay, so let me explain this in other words. Okay, derivative of f times g plus f times derivative of g. How many times did I take the derivative of f in this statement? Once. How many times did I take derivative of g? Did I take them back to back? No, I'm not doing f prime times g prime. Okay, and there's a plus in between. So if you get mixed up in the order, it's okay, because when you add, does it matter the order that you add in? Nope. When you multiply, does that order matter? Nope. So this formula is almost foolproof as long as you remember that you're not doing derivative times derivative, that it's a little bit more complicated than that. So looking at number 1, let's say that the first one, let's call that f of x, and the second one we'll call g of x. And you're going to find out really fast if you need the formula. If so, you got to memorize it and maybe write it at the top of your test, or if you can kind of work your way through it without really thinking of the formula. So the first thing we have to do is take derivative of the first group, and the parentheses show me what the first group is. So what's that derivative? 2x plus 3. Okay, then just the second group, 2x minus 5. Don't take derivative of the second piece yet. Plus. Then we're going to just write the first function, x squared plus 3x plus 2. And then times the derivative of the second function. And what would that be? 2. And that's your answer. You don't have to simplify. At some point in the near future, we are going to work on simplifying in the case that we have a multiple choice question. But for today, I just want to focus on learning how to set it up. We'll worry about simplifying later. On the test, this is perfectly acceptable for a final answer. In fact, I don't even want you simplifying because you don't get any more points for that, and you just have a possibility of making a mistake. Okay, so let's look at this next example. There's no parentheses here, so let's write them in. 4x cubed would be one group, and sine x would be another group. In the future, you're going to know you're going to need product rule when you see x in 2 different places. That's a really good indicator that you're multiplying 2 functions of x. And so again, if you need to, write a little f of x and a g of x. If you're like, well, I'm just figuring it out using the language of what Ms. Brooks is saying, that's fine. If you're really referring back to the formula, then you write that down. Okay, k prime of x. What's the first thing I'm going to write down? Derivative of the first thing, which would be 12x squared. Good. Then just sine x plus. And then you switch which one you take derivative of. So it's just 4x cubed and times the derivative of sine x, which is cosine x. And that's your answer. So you should kind of start to realize, like, hey, am I using the formula, or am I just using the fact that I'm doing derivative of one times the other plus switch it? Okay, you don't have to know the formula, but you do have to know the rule. All right, let's try the next one. Number 3 is different. Okay, see that squared? I haven't told you how to deal with that squared yet. I know how to do x squared, but we don't know how to do a function squared. So let's rewrite it without the squared. What would we need to do here? Times, same thing. So 4x squared plus 5. Okay, so now I have an f of x and a g of x, and they happen to be the same thing, but you don't have to really pay attention to that part. I want you to try to do this one on your own, and when you're done, I want you to check it with someone around you.
Because I don't know. I feel like good about it, but he got it.
Okay, so your answer should have been f prime of x equals 8x times 4x squared plus 5 plus 4x squared plus 5 times 8x. Derivative of the first thing. So if you're still struggling with, like, how did you get from 4x squared plus 5 to 8x? Please come to tutoring. I can explain it to you a different way, but at this point I'm going to assume y'all understand that. Then just the second thing plus, and then you write the first, but you take derivative of the second. Okay? That's your answer. Do you guys see how that was like itself plus itself? So we could go 2 times it, and the power was 2. Interesting. We're going to learn about that next week. That's called chain rule, and that's all you get for now. Moving on. Okay, quotient rule. Okay, if someone just walked in and we forced them to tell us what they think quotient rule is, they'd probably say f prime over g prime, right? It can't be that simple. Okay, or they'd say, what? What are you talking about? All right, so it's very similar to product rule. First of all, there's going to be a big fraction bar because these are fractions, right? Okay, so this is how the top goes. Really similar to product rule. Okay, f prime, the derivative of the top, times just the regular denominator, g of x. Now with product, we had a plus here. Anyone want to guess what we have with quotient? A minus. You guys are so smart. All right, so then what do you think goes next? F of x times g prime. See, you already know this rule. Someone already taught this to you. I'm just kidding. All right, so it's very similar to product rule, except there's a minus. And then the only other thing is there's also a denominator. The denominator is going to be what the denominator is, g of x squared. Now, I'm not proving these formulas to you. We could do that. It would take a lot of time, and in the end, you still just got to know the rules. So I'd rather spend time going over examples. All right, so let's look at 4. Okay, here, the top is the f of x, the bottom is the g of x. And we want to find what is y prime. This is a very classic quotient rule problem, something over something. So let's put a big fraction bar. And what we start with is the derivative of the top. So what is the derivative of 7x minus 5? 7. And I'm going to go ahead and use parentheses even when I don't need them, just to keep it consistent. Then times the denominator, x squared plus 3. Remember with quotient rule, we're going to have a minus here. So minus just the regular numerator times the derivative of the denominator, which would be 2x. Okay, all over the denominator squared. And that's your answer. You do not need to simplify. Don't simplify. Just leave it like that. We'll worry about that another day. Okay, I do want to point out something before we move on to the next example. In how many places did we take derivative of the top? Once, right there with that 7. In how many places would we take derivative of the bottom? Once. That's always going to be the case. If you're taking derivative of a single piece multiple times, you're doing this wrong. And so that's a way you can kind of at least catch some mistakes. Okay, so number 5 is pretty similar, except we have that 1 over x. What's a way I could rewrite this 1 over x? 3 minus x to the negative 1. Good. So this is not taking the derivative. This is just like my prep work. Okay, so let's actually find the derivative here in the bottom below this. One thing is, if you know you're like a careless mistake person, some of you know you're the person who always forgets that thing that you're supposed to do at the end. If that's you, I would actually just go ahead and start with the last step. Go ahead and put that denominator squared, because that's the part that I see people forgetting. They forget that there's a denominator. All right, so then remember, up at the top, we go derivative of the top. So derivative of 3 is 0. Negative 1 times negative is a plus. And then the new power would be minus 1 from negative 1, which would be negative 2. Now, you don't have to write the 0 plus part. So whatever you write, as long as it's equivalent to the correct answer, you're good. Okay, what am I doing next? X plus 5, right? You take derivative of the top times just the bottom, minus just the top times the derivative of the bottom. I hope it's not a lot because I only left a little bit of space. So what is the derivative of the denominator? 1. And by this point, I'm hoping you guys feel really comfortable with power rule. If you're still struggling with power rule, this is like really overwhelming probably.
If you multiply it out, would you distribute the minus one?
Yes. She asked if we did multiply it out, would we distribute the minus? The answer is yes, you would. Okay, so let's go back over here to this problem 6, and it's not a fraction. Or is it? Yep. Remember trig proofs? Okay, one reason you did trig proofs is so that you got really comfortable with certain identities, and this is one of them. You need to know that tan x is the exact same thing as sine x cosine x. So by writing it as a fraction, oh, I know how to take these derivatives. So let's do y prime. Okay, a big fraction bar. Go ahead and see how far you can get on this one. And we are going to simplify this one. So if you want to try that part on your own as well, go ahead. There's a reason. I'll let you know why, or maybe you'll tell me why. Okay, derivative of the top was cosine times the bottom minus the top times derivative of the bottom. Did everybody remember this minus right here? Over the denominator squared. Okay, so really, if this was all we were doing, this would be fine. I encourage you guys to go ahead and multiply it out, see if you could simplify it. And so this is what I mean. Cosine times cosine, we write as cosine squared x. And you guys know the reason we write the squared here is so that we don't confuse it with just x being squared. The whole thing is being squared. That's why the 2 is there. Okay, minus a negative would make a plus. And then I'm going to do the same thing with this cosine squared. I'm going to write it like this. that top is something we call the Pythagorean Identity. Do you guys remember? It's 1. Okay, we normally see it as sine squared plus cosine squared, but that's 1. That was called the Pythagorean Identity. Now, you're not going to have to do this every time. There's a reason I'm kind of going forward in this, and it's because we're going to develop a new rule. What is the reciprocal of cosine? Secant. So you now know that the derivative of tangent is secant squared. That's interesting. Or not. It is to me, but it may not be to you. I get that. Okay. So I want you to flip the page over, and let's go over all the trig that we know, and then we'll go over the ones we don't know. Bless you. Okay. Do we know the derivative of sine? Snow cone, snow cone. It's cosine. All right. Do we know the derivative of cosine? Negative sine. Okay, so I'm going to bring up a point here. The derivative of a co is a negative. We're going to see that happen again. The derivative of a co function is has a negative always. Okay, what did we just discover the derivative of tangent was? Secant. Well, we discovered it was a lot of things, but in the end, it was secant squared x. Okay, so watch what I'm going to do here. I want you to really listen. I'm going to emphasize certain words. Derivative of tangent is secant squared. Derivative of cotangent is negative cosecant squared. Isn't that nice how that works out that way? We could do another proof of this using quotient rule, but I would really rather spend the time doing these examples down here. All right, so let's go over the last one. Okay, and again, I could prove this to you. In the end, it's just something you're going to have to memorize. Okay, derivative of secant is secant x tan x. Sometimes you'll see this written as tan x secant x. These are being multiplied here. Okay, before we get to this one down here, I want to show you something that may help you. Look at what's happening here. I see 1 tangent, and how many secants? 2. 1 tangent, 2 secants. Over here, again, 1 tangent, 2 secants. That may help you remember this. In the end, this is something you have to memorize. Flashcards, writing it down, whatever works for you. Okay, and this will be on the test on Friday. So you already had 2 of these memorized. In my opinion, you really only have to memorize these 2, which are kind of related with the whole 1 tan, 2 secant thing. Okay, and I also gave you the pattern of if you know secant, then you should know cosecant. So first of all, what do we know about the derivative of cosecant? It needs to be negative. Okay, if secant derivative was secant tangent, cosecant should be negative cosecant cotangent. See how the co's just fall in line? You get a negative, and then you just co everything. Okay? If that doesn't help you, then memorize the 6 individually. Just play to your strengths. If you're a pattern person, use the patterns. If you're a memorizer, memorize them. Either way, I cannot stress this enough, you need to memorize these trig derivatives. You kind of get stuck on a problem like 7. Or it's not necessarily that you get stuck, it's just that, oh, well, right in the middle of the problem, you're going to have to change this to 1 over cosine and do a quotient rule. Which you could do, but that's going to be very exhausting after a while. It's easier just to memorize them. Okay, so let's look at number 7. All right, tell me, am I going to need to use product rule or quotient rule or anything like that on this one? If this had been, don't write this, but I want you to look at what I'm doing. If this had been a 2, we would just go 2 times the derivative of secant. But it's not a 2, it's an x. So we do have to use product rule. Okay, anytime you see x in more than one spot in both groups, even if there's no parentheses, put the parentheses in, and we need to do product rule. Okay, so what would be the first thing I write be?
Derivative of x.
Which is 1. So derivative of the first piece, which is 1, times just the second piece, plus for product rule, just the first piece times the derivative of the second piece, which we just, if you look right up here on your paper, is secant x tan x. Don't forget those x's. Trig doesn't mean anything unless there's something after it. You always got to have the x after it. And that's our answer. Okay, let's look at number 8. I have 3. We don't have a rule for 3, so we're going to have to just do with what we got. Okay, watch what I'm going to do here. And this, as you can tell, doesn't have any trig. I'm going to group these two together. And this is going to be my little f of x. And this piece is going to be my g of x. And let's just change this f to an h just so we don't have f's in 2 different places. Okay, you have options here. You could take these first 2 things and multiply them together, like distribute them and all that, and then it would be like a normal product rule. Totally fine. I am going to do it a different way just to show you how that can be done. Okay, so watch what I'm going to do here. H prime of x equals, okay, for a minute, I'm just going to ignore this g of x right here. Okay, I'm going to ignore it. I'm just looking at this piece. So so it's like a little mini product rule within the larger product rule. So derivative of the first piece would be 2x minus 1 times just the second piece plus just the first piece times derivative of the second piece. Okay, and everything that I just wrote is the derivative of this chunk right here. In other words, this is all f prime of x. Okay, what should I write next after f prime? Regular g, which would be this x squared plus x plus 1. And it's product rule, so I need a plus. Now I get to just write regular f of x. X squared minus x, x squared plus 1. And I'll have to write this one like sideways. Now I get to take derivative of the second group, g of x, and that would be 2x plus 1. And as messy as that is, it is your final answer.
Or you could just distribute.
If you want to, go for it. So I've written it down here in case you were not sure about where I got which piece, but are there any questions about why I wrote something in a certain spot? That's super messy. How many of you are like, it would have been easier just to multiply this through? Yeah, I agree with you. It would have been. So on 9, we don't have the option of distributing. There is some distributing we could do, but it would end up being a lot more difficult. So look at 9. I have a quotient and I have a product. But if you label one with f of x, and I'm just going to start using f and g instead of x, just to save a little space. We have fg. Are we doing f divided by g or times g? Times. So this is a product rule. So if you're like, I don't know if it's product within quotient or quotient within product, but what we need to do here is do f prime times g plus f times g prime. So this is where the formula could help out a little bit. This is where knowing the formulas are good because it can kind of guide you through if you're getting confused about what to do each time. So the first thing I need to do is f prime. Well, what rule do I need to do in order to do f prime? Quotient rule. So I have derivative of the top, and I'm going to go through this particular part faster, times the bottom minus the top times derivative of the bottom, all over the bottom squared. Okay, all I've done so far is this first part. But that's the hardest part. Okay, so all of this is just the derivative of that first thing in parentheses. Then I need to write g x cubed plus 5x minus 7 minus, and I'm going to write the second part down here just so I don't have to write tiny. Just the first thing. Notice I'm not taking derivative again. You only take derivative of each individual piece one time. Yes, sorry, thank you. This should be plus because we're doing product rule. Thank you. That's what I get for talking and writing at the same time. Okay, and the very last thing we need to do is the derivative of this g piece. So that's going to be 3x squared plus 5. It's very easy to get lost in this problem. So one thing you could do to kind of help you figure out is just notice each of these pieces. You should have only taken derivative of any piece one time. Okay, so see this 4x plus 3? That was the derivative of the top piece. This 2x, that was this piece. This 3x squared plus 5, that's this last piece. You shouldn't be taking derivative of any one piece more than once. That's a way that you can kind of catch some mistakes. If you're like, man, I was good on the front, but this is bad. Okay, this is obviously harder than what we did on the front. Okay. All right, 10. Last problem. Okay, is this a product rule or a quotient rule? Or both? Both. Now, if I label this as F and this is G, and again, this says G over here, so let's change that to an H. There is kind of like going to be a mini product rule within the larger quotient rule. So if you're like I need to set up the framework, and then I need to fill in the blanks. What you could do is just, now I know this first blank is going to be really big, so I'm going to do like that. And then start with what you know for sure. I know that denominator has to be the same denominator but squared. And if you didn't know this first blank had to be really big, that's okay. That's what your eraser's for. Why did I draw this first blank really big? So I could do a product rule right here. So forgetting about the 1 minus cotan x for a minute. Derivative of the top, 1 times the bottom, plus just the top times derivative of the bottom. And I almost left myself enough space, but not quite. So times the denominator minus the numerator, and then the last thing would be derivative of the denominator. That still didn't leave my mouth. Okay, derivative of 1 is 0. What's derivative of negative co? Anything. What's the derivative of any co? Negative, we found out. So, and minus a negative is going to make a plus. Derivative of tangent is secant squared, so cotangent would be cosecant, cotangent. Sorry, cosecant squared. I don't know. Hold on. Let me just back up. Cotangent is going to be negative cosecant squared. And so I'm making it a plus because it was minus a negative. Okay, like really, these last three are really stepping it up. That's not the standard. Those are the challenge problems. Yes?
So for the first, like, multiplication one, isn't cosecant, isn't it negative cosecant times cotangent x.
You're right. What did I do here?
I don't know. I think it's about
I saw that as secant. Yeah, hold on. This is good. And for everybody watching the video, just be like, oh, Miss Brooks, you know her. Okay, cosecant x. Even though I've worked this problem twice today, I was reading that as secant. It's obviously cosecant. So I'm going to do this in another color. Thank you, Will. And so what is the derivative of cosecant? Negative cosecant x cotangent x. Thank you.
And then you changed the latter part.
Yeah, right here. That would be, let me erase it. I just read that wrong, and which is really silly considering this is the third time I've worked this problem today alone. All right. If you feel good about the front, but you're like, oof, the back, that's not a horrible place to be in right now.